Red dwarfs are the smallest, dimmest, coolest and most common type of main sequence star in the universe. Main sequence means that they're still making heat and light by fusing hydrogen into helium in their cores. The characteristic properties of red dwarfs stem from their low mass, which ranges from less than a tenth to about a half that of the Sun. Their low surface temperature in the range 2300 to 3500 Celsius is what gives them their reddish colour, while their combination of low temperature and small surface area results in them being very faint. Red dwarfs survive longer and are more numerous than any other kind of star. Of the 60 nearest stars to the Sun, 50 are red dwarfs. The nearest star of all to the Sun, Proxima Centauri, a member of the Alpha Centauri system, is a red dwarf, as is the next nearest star system, Barnard's star. According to some estimates, red dwarfs make up at least 3/4 of the stars in the Milky Way. The coolest red dwarfs have a surface temperature of about 2300 Celsius, and the smallest have radii about 9% that of the Sun, and mass is about 7.5% that of the Sun. There's some overlap with the properties of brown dwarfs, which are classed as substellar objects. Theoretical models indicate that in red dwarfs weighing less than a third as much as the Sun, the helium produced by fusion of hydrogen is constantly remixed throughout the star, avoiding a buildup of helium in the core. This greatly extends the period over which fusion can take place. Low-mass red dwarfs, therefore, develop very slowly, maintaining a constant luminosity over trillions of years. Because this is many times the present age of the universe, no red dwarfs yet exist at advanced stages of evolution. Like other types of star, red dwarfs are often accompanied by planets. It's unusual for them to have big planets like Jupiter, but they frequently have planets similar in size to our own, super-Earths or Neptune-sized worlds, in their so-called habitable zones. The habitable zone is the region around a star where liquid water could potentially exist on a planet's surface. Evidence suggests that life might have a hard time developing and surviving on the planets in a red dwarf system. First, planets in the habitable zone of a red dwarf are so close to the parent star that they'll likely be tidally locked. For a nearly circular orbit, this means that one side will be in perpetual daylight and the other in eternal night. This would create enormous temperature variations from one side of the planet to the other. The night zone would be cold enough to freeze the main gases in the atmosphere, leaving the daylight zone bare and dry. On the other hand, it's possible that either a thick atmosphere or planetary ocean could potentially circulate heat around such a world. Variability in stellar energy output may also have negative impacts on the development of life. Red dwarfs are often flare stars, which can emit gigantic bursts of radiation, doubling their brightness in minutes. This variability would pose major problems for the survival of life as we know it. However, there's some room for hope. The red dwarf known as Gliese 581, which lies about 20 light-years from the Sun, is both very old and relatively inactive. It's known to have at least 3 planets going around it, 2 of which lie within the star's habitable zone. Gliese 581c and d are 2 of the most likely candidates for habitability of any exoplanets discovered so far. TRAPPIST-1, 39 light-years away, is another red dwarf of interest to astrobiologists. No fewer than 7 Earth-sized planets have been found in orbit around it, at least 3 of which are in the habitable zone. TRAPPIST-1 will be a prime target for investigation by the new generation of telescopes, including the James Webb Space Telescope and the extremely large telescope currently under construction.